Hi, Dr. P here, and in this lecture video we're going to take a look at significant figures and calculations. Now, why do we worry about significant figures? In fact, what are significant figures? Well, the significance, for lack of a better word, of significant figures is that they allow us to say something about the precision of a measurement. For example, let's say I have the following three numbers. Let's say I had the following three measurements. Let's say, I don't know, this is miles per hour. Let's just say. Now, if they're written like this, it means something very different than if I had 61.0, 60.0, and 59.0 mph. Okay. Now, why is that different? Well, our last digit is our first uncertain digit. And I mentioned that last time. And that guy is certain. So over here, our last digit here, our first uncertain digit, is 0.0. And these guys are certain. So what we're really saying is that when we say we have a measurement of 61 miles per hour, 61 miles per hour is really 61 plus or minus 1 mile per hour. Okay, that uncertain digit, unless we say otherwise, has an uncertainty of plus or minus 1 of that unit. So given that 61, our measurement here, could have been actually 60 or 62. And 60 could be 59 or 61. And 59 could be 58 or 60. So when I have only these two significant figures, really I should put a decimal point there, we'll talk about that in a minute. When I have just two significant figures, I really couldn't differentiate between these three measurements. However, when I have 61.0 mph, that's really 61.0 plus or minus 0.1 miles per hour. So then my 61.0 could have been 60.9, or it could be 61.1. My 60.0 could have been 59.9 or 60.1. So 60.9, 61.0, 61.1, 59.9, 60.0, 60.1, 58.9, 59.0, 59.1. It could vary anywhere in that range. And so these three measurements really are different than each other, and it has to do with the number of significant figures. All right, so what are our rules here? I'm going to abbreviate significant figures as sig figs. So all certain and the first uncertain digits are significant. In fact, we don't even report digits that aren't significant after our first uncertain digit. Okay, so we don't write down later uncertain digits. Now, there are some other rules. Let me set that aside here. all non-zero integers are significant. So if we have, anything from 1 to 9, that is significant. For example, 1, 2, 3, 1.414, 2.78, 1828, 1828, 459045. This guy has 3 sig figs. This guy has 1, 2, 3, 4 sig figs. And this guy has lots, and actually there's a 0 in there, so this is a bad example. So I'm going to cross that guy out for just a sec here. We'll come back to it. Zeros are a little different. If we have leading zeros, those are not significant. So for example, if I had 0.0023, that would be 2 sig figs, because all of these zeros don't count. Another way to think of that is if we wrote it in scientific notation, it would be 2.3 times 10 to the minus 1, 2, 3, minus 3. And now we see pretty clearly we have 2 sig figs. So it's important to be able to use scientific notation. It can be very helpful when writing out, basically for determining your number of significant figures. If you don't feel comfortable with writing things in scientific notation, go ahead and take a look at a little refresher in the text. And plus you can check in with me in office hours. Okay, next we have captive zeros. Those are zeros that are in the middle. They're in between non-zero digits. Those are significant. So you can think of a leading zero as really just a placeholder. The captive zeros are significant. So let's say I had 2.005. That would be 4 sig figs. In this case, the captive zeros are significant. If I had 1.4130204, I've got 1, 2, 3, 4, 5, 6, 7, 8 sig figs. Next, we have trailing zeros. And trailing zeros are significant if a decimal point is present. Let me spell that correctly. Significant if decimal point is present. So some examples. Let's say we had 20.0, that is 3 sig figs. 20 point is 2 sig figs. And 20 is just 1 sig fig. Oops. Now, this may look a little awkward having a decimal point at the end of a number like this, but it is helpful. Now, we can also just write things in scientific notation. 2.00 times 10 to the 1 times 10 to the 1, 2.0 times 10 to the 1, and 2 times 10 to the 1. And now we can see pretty clearly, yes, we have 3 sig figs for this case, 2 for this case, and 1 for this case. Scientific notation is really helpful if you wanted to write, let's say, the number 10,000 to have only 2 sig figs. You really can't write it without using scientific notation. But we can talk about that in class. I think maybe we can discuss that. All right. Let's take a look then, now that we've gone over these significant figures. One other category, which is exact numbers. Sometimes you run into numbers that are exact. And exact numbers have infinite significant figures. That is, they have as many sig figs as you need to do a calculation. Examples of these include counting numbers. I'm going to abbreviate numbers with the pound sign here, number sign. Counting numbers and defined numbers. So some examples here. Let's say we had a dozen roses. So 12 roses. That is exact. There are exactly 12 roses. You know, I go and buy my wife 12 roses and I get 12. I don't get 12.1, I don't get 11.75, I get 12. Another example is 1 inch equals 2.54 centimeters exactly. So this is something called a conversion factor, which we'll look at in the next lecture. But sometimes we have something equal to a certain amount of something else, and that is an exact number, even though, you know, here we only have, it looks like it's only 3 sig figs. Well, actually, it's as many sig figs as we need. Usually these will say when they are exact numbers. Okay. Now, what do we do with our sig figs? Well, let's say we do calculations. You will do a bunch of calculations this semester. So if we do multiplication or division, our answer is going to have a number of sig figs that is equal to the number of sig figs in the least precise number. So the number of sig figs in the answer equals number of sig figs in least precise number. Another way of saying that is the number with fewest sig figs. Here I'll use the w/ to indicate width. So an example here might be, let's see, 1.23 divided by 5.78, and let's do this a little different here. Let's do 1.23 divided by 5.781. There we go. And I don't happen to have my calculator present here, but I do have one on the computer, so let's give this a try. 1.23 divided by 5.781 gives me 0.212765, etc. Well, I've got 3 sig figs on the top and 4 sig figs on the bottom. So my answer should have 3 sig figs. So this would equal 0.213. Why 3? Well, I'm rounding here. Okay, so remember your rules for rounding. So we're going to look at the first non-significant digit. And then if the digit is less than 5, we just drop the digit. The preceding digit will stay. If it's greater than or equal to 5, the preceding digit increases by 1. Now I will mention that in the text there's actually a slightly different rule for rounding when your digit to be dropped equals 5. So if I was going to be potentially dropping that 5 there, I'd have a slightly different set of rules. However, these rules are the ones you've probably seen already, and they're what calculators end up doing. Typically this is fine to do at the end of a long series of calculations, but if you have to do intermediate rounding, then sometimes it's better to do it the way that the text mentions. But I don't want to make things too complicated for you right now. All right, so that was multiplication and division. The number of sig figs in the answer is equal to the number of sig figs in the number that had the fewest sig figs. For addition and subtraction, if I can spell right, it's not significant figures, it's the number of decimal places. And that equals the number of decimal places in the number that has the fewest decimal places. So let's say I was adding up 1.23, 5.781, and then 6.9. If I add all these guys up, what do I get? I'll go back to my calculator here. And 1.23 plus 5.781 plus 6.9 gives me 13.911. 13.911. But my fewest decimal places is from 6.9, so I want to cut my number off here, so I should have 1 decimal place. So my answer is going to be 13.9. All right, so there are practice problems where you can practice this, and I highly recommend doing that. We'll have some time also in class, in lab, and in the class activity to do some work with significant figures. And it's important to be able to determine the number of sig figs correctly and do calculations and get the correct number of sig figs at the end of the calculation. That's going to happen over and over and over again. And I do actually take some points off my organic chemistry students' lab reports if they have their sig figs wrong. Like if they should only have 2 sig figs and they write down 5, Well, that's really not right. So you want to get to the point where it's sort of second nature that you are writing the correct number of sig figs. All right, well, that's it for this lecture. In the next lecture, we'll take a look at dimensional analysis or unit analysis and its ways of converting from one set of units to another and solving problems. All right, until then, stay safe out there. Bye now.